All right, question 3 says, consider the vectors v, which is 3i minus 4j, and w, which is 2i minus 3j plus 6k. Compute each of the quantities described below. So for part A, we're looking at 5v minus 2w. So 5v, just scale the components of v by 5, so 15i minus 20j. And then for 2w, just scale the components of w by 2. You get 4i minus 6j plus 12k. And then to take the difference, right, we just want to combine respective components. So 15i minus 4i, that's 11i, minus 20j minus a negative 6j, so plus 6j, that's minus 14j. And then the k component of v is 0, right? You don't see a k there. And so I'm just going to get a negative 12k for the k component of 5v minus 2w, and there's our answer. All right, cool. So for part B, we're looking at the magnitude of the difference, right? V minus w. So first off, what is v minus w? Well, 3i minus 2i is 1i, minus 4j minus a negative 3j. So that's minus 4 plus 3 is negative 1j. And then for the k component, I'm just going to get a minus 6k. So now I want to take the magnitude of this vector. So that's the root of the sum of the squares of the components here. So 1 squared plus negative 1 squared plus negative 6 squared. Okay, that's 38. So our answer there is the square root of 38. Now for part C, it might look deceptively similar, and you might even guess that it's really the same thing as what we did in part B. But notice the order of operations here is different. Okay, so in part B, we found the difference of the vectors, and then we computed the magnitude. In part C, we're going to find the magnitudes first of the vectors v and w, and then take the difference in those magnitudes. So what do we get? Well, the magnitude of v, that's the root of 3 squared plus negative 4 squared. So that's the root of 25, which is 5. And then for the magnitude of w, that's the root of 2 squared plus negative 3 squared plus 6 squared. That's the root of 49, which is 7, and that difference there is negative 2. So we see that the order of operations here being different does result in a different answer. So these two quantities here in general are not the same. All right, so now pressing on to part D. All right, it says find a vector parallel to v with magnitude 15. Well, noting that the magnitude of v is 5 that we saw back here in part C, if I want to find a vector parallel to v with magnitude 15, here I'm going to go ahead and just scale v by a factor of 3, right? It'll have magnitude 5, 5, 5, well 15, and 3v has the same direction as the vector v. So 9i minus 12j is one such answer. Now, if it just says parallel, I could also consider negative 3v. Okay, this vector, even though it points in the direction opposite to the vector v, it is still considered parallel to the vector v. Okay, it does not say it has to have the same direction as v. So more generally speaking, right, two vectors are parallel, okay, provided their directions lie along the line spanned by any one of the vectors. So here, right, minus 3v is parallel to the vector v, because if I consider this line spanned by the vector v, minus 3v, right, does point along that line. Okay, so both have magnitude 15. They're both parallel to v, so really either one of those answers would do. Okay, now before we jump into part E, I want to introduce an important idea that we're going to see quite a bit of moving forward. This is what's known as a unit vector. So you know the unit circle, right? That's a circle of radius 1. So a unit vector, right, this is a vector of magnitude 1. And in particular, if I want to find, say, the unit vector in the direction of a non-zero vector v, so here's a vector v, I'll call that vector, say, u. So it has magnitude 1, and it points in the direction of this vector v. So if I know v, how can I build u? Well, let's say the vector v has magnitude 7. So the length of this orange arrow is 7. To get to the vector u, well, I just want to scale v down. And what should be the scalar multiple? Well, I'd want to scale it by 1/7, right? 1 over the magnitude of v. So more generally, the unit vector u in the direction of a non-zero vector v is just v over its magnitude. Okay, so now looking at part E, this says build a vector with direction opposite that of w, and it has to have magnitude 4. Okay, so here's the vector w, and as we noted back in question C, magnitude of w is 7. Okay, so I want to build this vector, right, that points in the direction opposite w, and it has to have magnitude 4. Okay, well, one way to do this is to consider the unit vector in the direction of w. So just take w, divide it by its magnitude. So I'm going to divide w by 7, right? And we note here, right, that since w has magnitude 7, right, if I find the magnitude of the vector u, well, I'm going to get 7 over 7, which is 1. It's exactly what I want. All right, now to build the vector that I'm ultimately after, this vector in green, what I'm going to do is just flip over u, so consider negative u, and then scale it by 4. Okay, so this vector, minus 4u, this will satisfy this criteria, right? It'll have the direction opposite my vector w, and it'll have a magnitude of 4. Okay, so breaking this down, minus 4u, that's minus 4 times w over 7. And notice that's really the same thing as just taking negative 4/7 and multiplying that by the vector w. So in other words, if I scale w by 4/7, the 1/7 scales me down to a magnitude of 1, and then the 4 bumps me back up to a magnitude of 4, and the negative is just turning the direction around. Okay, now in components, this would be negative 8/7 I plus 12/7 j minus 24/7 k. Awesome. All right, well, that does it for this question. Thanks so much.